somewhat inefficient. One is you can use your table kinda. You can use your table. Watch. Let me turn this off. So you gotta find x. So y equals 40, yes? The problem with the table is you can't enter a y value and have it give you the x value. It doesn't work that way. And I'm glad it doesn't work that way, honestly. I'm glad it doesn't work that way for very good algebraic reasons. So one thing you can do is you can kind of keep guessing at x values until you get to 40. And we've kind of done a pretty good job of that right now. We've put a bunch of x values in here. 2, 4, 5, 6, 8, 10. The closest one is 6, which is a 39.4. But who's going to guess 6.6 or 6.57, which actually gets us even closer? Nobody's going to guess that, right? Because it becomes annoying. You can keep refining your guess. You might say, oh, so it's somewhere between 6 and 8. So then you can clear out your list. And you can go, okay, 6 and 7. Okay, 39.4 to 40.45. It's obviously bigger than 6, but less than 7. So you can go like 6.1. Okay, that's still too small. 6.2. Okay, although this is sometimes a good way of solving problems. I'm not saying it's not ever a good way of solving problems. It sometimes is. It sometimes is. There's a much more direct way of doing it, using your TI, not using a table. Tammy, what do you got?
You have a second calc, and then you just put x equals 6.6, and it tells you what your y is, which it says is 39.6.
Good. Hold that thought. Hold that thought. So you can use, this is a trick I wasn't going to talk about, but since you are, I think we should. Tammy is looking at the graph of her results. She's looking at the graph of her results. She pressed, it sounded like she pressed second trace.
Yep.
Second trace. What this is called the calculate menu. How many of you guys played with this in Math 95? Good. About a third of you. It's still, I wish it was maybe 2/3 bigger, but that's okay. There's a lot of goodness in this menu. There's a lot of goodness in this menu, believe it or not. A lot of goodness. It looks like a bunch of gibberish. A lot of goodness. A lot of goodness. One of them is called value. Value allows you to put in any x value you want and get out any y value. Problem is, you can't put a y value in and get out an x value. So you put in an x value of 6, correct?
I actually put 6.6 in.
Well, okay, but how did you get 6.6? Because we had it over here, right?
Yeah.
Right, but my question is, if you didn't have that to start with, you'd have to refine your guess down to get it, and take a bunch of time to do it. Now, I'm thinking we should use this menu, but I want to use this guy, intersect. And the reason I bring him up is because you guys just got done doing a couple quizzes about equation boot camp, solving equations with graphs, yes? Solving equations with graphs. Now you have one graph right here. Y equals 1.05x plus 33.1. Can anybody think of the other equation we'd have to graph?
Y equals 40.
The only other equation you have is y equals 40 because it's up there. Find x so that y equals 40. So now what you do is you'll go into your y equals and graph a second equation. Y equals 40. Boop, boop, boop. Press graph. If you want, you can make it look different so it stands out. You can make it like, I'm going to make it thick shaded so when you see it come across it'll look different than the other one. Okay, here we go. You ready? Press graph. What does it do to your previous line? Intersects. Remember this from Equation Boot Camp. This is the whole point of me doing that, was because now we can use it in context. It becomes wicked helpful. I'm not saying you're going to always do it with a linear equation. These are pretty simple to solve, yes? But when they start getting to be exponential and quadratic and cubic with Usain Bolt's 2009 world record time, you're going to be wanting to do it this way. Because this is much easier than solving those things by hand, yes. Can we find that point right there? Hell yeah, we can. That's where that intersect command comes in. How many of you guys in 95 used the intersect command back in the day? Yes. If anybody has never seen this before, shoot me an email. I have a little booklet that walks you through this too. But because so many people have seen this and are comfortable with it, I don't just print out copies of it. I'll happily send you one if you want one. Just send me an email, I'll shoot it off to you. Or if you need a refresher, I can do that too. Intersect. Now the first thing it asks is which of the two equations do you want to intersect? Because the TI, it's a computer. It's not smart. It's fast. It's not smart, it's fast. It can't read your mind. It can't look at that and go, oh, I can see that there's an intersection point. It can't see anything. It doesn't see anything. It just computes. So it says, should I use y equals 1.05x plus 33.1 as my first graph? What do you think? Well, yeah, that's part of the problem, right? 1.05x plus 33. So you press enter. That says yes. Okay? Should I use y2 equals 40 for the other one? If you can imagine the quiz you guys turned in last week, these are like the two different colored curves crossing each other. You're picking the two different colors, just like your eyes had to do on the quiz. Now, at this point, it asks for a guess. This really isn't necessary. It's kind of an archaic holdover from the old technology days. You don't have to give it a guess. It'll find it just fine. When you press enter, what it's going to do, and this is fascinating, when you press enter, some of you already have and you're already done. That's fine. But what it does is, it starts close to where the guess is, and it starts evaluating y values on both of the things you selected. And it keeps doing that until those y values match each other within a certain tolerance. Right now, if it checks it over here, for example, if I pick my guess over here, it's going to check the y value there, which is 40, and the y value down below, which I can't get to, which is obviously below 40. Then it's going to move to the left and check again. 40, below 40. 40, below 40. But getting closer, yes, but getting closer, but getting closer, but getting closer. Now we're past it. Now, this one's going to be 40, but this one's going to be over 40. So somewhere between, they must have crossed to have it switch. The computer does that, well, like that. It does it that fast. And it finds 6.57. Sound familiar? Yes. Sounds familiar. 6.57, 6.6. 6.6. But it does it extraordinarily quickly. That's why we use computers. That's why computers were invented, believe it or not. It wasn't to check Twitter accounts and Facebook status. It was actually to do stuff like this, believe it or not. And then we kind of lost sight of that. That's okay. Fair? You can solve any equation this way. I promised you that on the first couple weeks of class with the equation boot camp. If you have a graph of the equation you need to solve, you can use the graph to solve it. It's just a matter of being able to visualize the intersection points. Once you visualize the intersection points, that's where the solution lies. Now, you would only write down x equals 6.6. There's no reason to write y, correct? Because number one, you already knew y was 40. You're not giving me any new information. And number two, you're finding x. You're finding x. Fair? Believable. You guys look sauced. It's time for a break. Go walk. We'll interpret when we get back. Yes. What you do? You can't see. I see the whole... I'm glad.